Hi guys, these notes are kind of long. The vertical asymptotes are considered non-removable discontinuities because I can't just like fill it in and change it and make it look nice. The vertical asymptotes will stay. Again, that's something to worry about in pre-calc and calc, but something some of you might see sometime. All right, so what are these graphs going to look like? So if you have one vertical asymptote and a horizontal asymptote of some sort, your graphs could look like this, where maybe you have something like that. You could have graphs that kind of look like the ones you did in 9.3, where they're like that. Or maybe if we've got a negative with a reflection in there, could maybe look something like that. Or what's the one I'm missing? Could go something like that. All depends on what the numerator looks like, but there's a bunch of different options. Okay, what if we have two vertical asymptotes? Lots of combinations here. I'll give you just a few examples. You might be able to have something that goes like this. Maybe you have something that goes like this. And maybe it's kind of a snaky looking one in the middle. Remember, asymptotes are approached. So I got to get close with the vertical asymptotes, but I also have to approach the horizontal asymptotes. Maybe in the middle I have sort of a parabola-ish looking thing, and then maybe this one goes this way and this one goes this way, again approaching that horizontal asymptote. Or maybe I have an upside down parabola-ish looking thing, and then maybe this one is down here and maybe this one is up here. Okay, or maybe I have a snakish looking graph in the middle, but it goes the opposite direction from the first one. And then maybe this is up here like this, and maybe this one's here like this. Lots of different options. But if you have two asymptotes in the middle, you'll either have a snakish looking thing going that direction or a snakish looking thing going this direction. And then you could also have a parabola-ish going up or a parabola-ish going down. And then the sides kind of do what they do, similar to what you have with just one vertical asymptote. I forgot to include slant asymptotes in here, but you could have a graph maybe with a vertical asymptote like that, and then a slant asymptote like this, and then maybe your graph is up here like that, and down here like that. So there's really all sorts of scenarios for these rational functions. Um, and we'll look at different ones. The interesting thing is that if we look at the horizontal asymptote in this one here, notice it's been crossed kind of between those two vertical asymptotes. And in this one too, here's our horizontal asymptote. It also has been crossed. So one of the things that you'll notice is that vertical asymptotes are never crossed because that's where the function, again, is undefined. So you'll never have a value there. But horizontal asymptotes can be crossed, but they'll always be approached at the extremes at negative infinity and infinity. So when you're going out towards the edges, you'll approach that horizontal asymptote. But in here in the middle, you can cross it. So it gets a little weird. All right, so let's look at an example and kind of what this is going to look like when we put everything together. So we've got 2x squared minus 9x minus 5 over x squared minus 3x minus 4. We're going to need to change what we're writing with. We'll have a 2x and an x. We need to factor this. Let's put a 5 here. That gets us a 10. And then a 1, 10. We need a negative 10 plus 1 will get us that negative 9x in the middle. Divided by here, if we factor this one, we'll get x minus 4 and x plus 1. All right, so the degree of the numerator, that's this highest power on the variable, that's a 2. The degree of the denominator is also a 2. So when those are equal, that tells us about the horizontal asymptote. That gives us the horizontal asymptote y equals leading coefficient divided by leading coefficient. So 2 divided by 1, which is 2. So we will have a horizontal asymptote there at y equals 2. Now, let's talk about this for a second. So since we have a horizontal asymptote, we don't have an oblique asymptote. All right, what values of x can we not have? Where is our function undefined? It's undefined when the denominator is equal to 0. So x cannot equal 4, x cannot equal -1. Again, that's where the function is undefined. So that is where our vertical asymptotes will be. So we'll have a vertical asymptote at x equals 4, and we'll have a vertical asymptote at x equals -1. So here's our vertical asymptote at 4, and here is our vertical asymptote at -1. All right, zeros, remember that is where the numerator is equal to 0. So where do those occur? Those will occur at -1/2 and 5. So if we transfer that into some x-intercepts, we'll have some x-intercepts at -1/2, 0, and at 5, 0. So -1/2, 0, and at 5, 0. So that's what our points are. And then I also want to talk about the y-intercept. Remember, that's when our x is equal to 0. So if we plug in, trying to shrink this a little bit. If we plug in 0 for x, we'll get 0 minus 0 minus 5 over 0 minus 0 minus 4. That gives us -5 over -4, which is 5/4. So 0, 5/4. That's 1 1/4. So 0, 1 1/4, it's going to go like that. Okay, so now what? So now we really have 3 regions we're graphing in. We've got this region over here. We've got this region sort of in the middle, and then we've got this region over here. And what is our graph going to look like? In the yellow highlighted region, it's easy to figure it out because I will either be up here or I'll be down here. Since I have this point here, I know I'm going to have to go through that point, so my graph is going to look like that. Okay? In the green region, I don't have any x-intercepts, so I don't have anywhere to cross the x-axis, so I can't be down below. So I'm going to have to be in the top region because I don't have any x-intercepts to cross the x-axis with. Then that leaves the middle region, the pink region. Well, I know I've got this point here. I know I got this point here, so I know I'm kind of going like that. But then the question is, do I continue going up like that? Or do I turn back around and go down? So what we'll have to do is we'll have to pick a point between 0 and 4 to see whether we keep going up or whether we start going back down. So I'm going to pick in the middle. I'm going to pick f of 2. So we're going to find f of 2. So I'm going to just plug it in the factored version because it seems like it'll be easier. It doesn't really matter. I don't know if it's easier or not. So we're going to plug in 2. What do we get? 2 times 2 is 4 plus 1 is 5 times 2 minus 5 is -3 over -2 times 3. That's -15 over -6, which is a positive 5/2. So I'm over here, 2 is at 2.5-ish. So that then tells me that I'm sort of the snake-ish going up because I won't be able to go back down. Oh, actually, I should have known this already because I won't be able to go back down like a parabola-ish because I don't have another x-intercept over here. So I should have been able to tell it goes up and we didn't really need to plug in this extra point. Now, 2 long videos, I know, I'm sorry, there's a lot to graphing, but we'll spend a couple days on it. This week Well, we'll spend Thursday on it, and then we'll spend some time on Monday on it as well. Okay. Um, okay, that's it. Sorry for the long videos, a lot to cover, and I'll see you guys. Well, let's see. You guys are the A students. I won't see you guys till Monday, but hopefully I'll see some of you on Friday, and you can dial into the Teams meeting and say hi and ask some questions. Okay? Have a good night, guys. Bye.